Hello, sixth graders. This is Mrs. Hebert, and we are working on lesson 16.3 today, box plots. And so you will need to create basically 2 pages. You'll need 5 sections. It will probably take 1.5 pages, but you'll use both the left and right sides most likely. So the first side will look like this, boxes 1, 2, and 3. Maybe a little more room at the bottom on number 3. And then on the other side, you'll have boxes 4 and 5. And you may use a little more room than I have here. You'll just have to see how it goes. Okay, in box number 1, we're going to write some definitions. So the first one is a box plot. So what is a box plot? A box plot is a display that shows how the values in a data set are distributed or spread out. Some terms you need to be familiar with when talking about a box plot are range. And the range is the difference between the greatest value and the least value in a data set. A lower quartile, often shown by a LQ, is the median of the lower half of the data, and the upper quartile, or the UQ, is the median of the upper half of the data. And hopefully that will make more sense when we do the box plots. Then the interquartile range, or the IQR, is the difference between the upper quartile and the lower quartile. Okay, in box number 2, you're going to want to write down all this information and leave some room to add some numbers. And then when you're ready, we'll move, you can press stop and then we can move on when you're ready. You can press play again. So the steps that you need to go through to make a box plot, basically what you're going to be doing are you're going to find some values. So the values you have to find are the least value of your data range. So, out of your values, what's your lowest number? Then you're going to have to figure out where your lower quartile is, which I'll show you how to do. Where your median is, which we've already learned how to do. Then your upper quartile and your greatest value. So really, you know how to do the least value, the greatest value, and the median. We just have to learn how to find the lower quartile and the upper quartile. So let's look at this example of students' heights in inches. So 60, 58, 54, 56, 63, 61, 65, 61, 62, 59, 56, and 58 are the different students' heights. So the first thing you have to do is order the data. So when we order the data, we're going to start with the least value, obviously, okay? And let me see. We're going to, in this case, the least value is 54, so we'll start with 54. Then 56, and 56 again, because remember I write it as many times as I need, as it shows up. Since it's in my chart twice, I put it in my order twice. 2 58s, so 58 and 58. I'm going to separate them by commas just to keep them separate. 59 60. 61 61. 62 63. And I wish I had room, but 65. Should really be in the same line. So out of these, we can identify some things very quickly, very easily, and I'm going to just get a different color. So we know the least value is 54, okay? And the greatest value is 65. Those are pretty easy. So let me see if I can get a color. So the least value is 54, and the greatest value is 65. Now, the next thing I have to find is the median. To find the median, I start from the outside and count my way in. So I'll use a blue for that. So 54 and 65, 56 and 63, 56 and 62, 58 and 61, 58 and 61. And then I have 2 middle numbers, so 59 and 60. So I know that what's halfway between that is 59.5, but if I didn't, I could add 59 plus 60, get 119, and I would divide that by 2, and I would get 59.5. as my median. So you put that in there. Okay, now, so what we're going to do next is we're going to figure out the lower quartile and the upper quartile. So basically what you're looking for is the lower quartile value is the median of the lower half of the data. And the way we do that is we use the median to divide the data set into two halves. If there's an odd number of data points in the data set, then you include the median in both halves, okay? But in this case, we have two numbers that make up the median. And so we're going to take, we're going to use the 59 for the lower quartile, and we'll use the 60 for the upper quartile. So we'll just divide it right in half there between the 59 and 60 at 59.5. And then what we do is we find the median. So the way we do that, let me see if I can find a different color. I'll do green maybe here. Okay, so I'm going to go here in this I'm looking in this lower quartile. So I'm going to go, I need a different color maybe. Let me try blue, perhaps. So here we go, 54 and 59. Maybe I should do a dot or something to make it look different. 56 and 58. And then I have 56 and 58. So I have to take the median there, and halfway between 56 and 58 is 57. But I could add those up and I would get 114 divided by 2 is 57. So my lower quartile is the median of the lower half. So it's 57. I know it's kind of hard to see there, but it's 57. I'll try to write over here. 57. Okay, for the upper quartile, because I have two values, I'm going to take the higher of the middle two numbers, so 60, and I'm going to find the median for the upper half. So 60 and 65, 61, and 63. And then I have two values, 62 and 61 and 62, so the median is 61.5. So the upper quartile is 61.5. So again, what I do to find the lower quartile is I find the median of the lower half of the values of the range. And then for the upper quartile, I find the median of just the upper half of the numbers. And so you divide the numbers, into the middle where the median is. And if you have an even number, then you take the, like in this case, 59 and 60, you take the 59 and use it for the lower half, and you take the 60 and use it for the upper half. But if you have a middle number, then if you have an odd number, let's say you had, I don't know, just say that the middle number was by itself and we weren't finding, and it was just the median by itself. And you would just use that in both values then to do the counting back and forth. Okay, so now that we've found our values, the least value is 54, the lower quartile is 57, the median is 59.5, the upper quartile is 61.5, and the greatest value is 65. So now we're going to draw what is called a box plot, okay? So to do that, I'm going to draw a number line that includes all the data values, all right? Basically meaning all the numbers. So I'm going to draw a number line here. And my numbers need to go from 54 to 65 because that's my range of numbers. So I'll start here with 54, over here with 65. And I know that, 60 is about halfway, maybe a little bit more. So I'll go put that kind of in the middle. And then I do 54, and I just try to space it out as good as I can. So 55, 56, 57, 58, 59. So 54, 55, 56, 57, 58, 59, 60, and then 61, 62, 63, 64, 65. Okay, so now I have these, and I'm not going to label every number just because I'm out of room, but you could certainly label every number. I'm going to put 56 there, and I'll do every other number just so that you can still make sense of my number line. Okay, now I'm going to do is change my color. Okay, it says, so I drew the number line. It has all the data values from the least value to the greatest value. Now I'm going to draw dots above all those values I found, those 5 values. So least value was 54. I'll draw a dot there above the number line. The lower quartile was 57. The median is 59.5. So you have to kind of estimate where that's at. Then the upper quartile is 61.5. And the greatest value is 65. So I drew a dot above all the numbers. That's why so I start that. And I'm just going to kind of label them here. So LV for the least value, GV for the greatest value, LQ for the lower quartile, UQ for the upper quartile, and then I'll put an M for the median. Okay, and I know it's kind of, I didn't give myself enough room there, but hopefully you can give yourself enough room to be a little bit better. Now, you're going to draw a box, which is why it's called a box plot, from the lower quartile, from the least value. Wait, how did I do that? Let me think. Okay, sorry. So you're going to draw a box from the least quartile to the upper quartile. So here's my least quartile, and I'm going to have to change pen colors. I think I'll just go with black. Hopefully you can see it. So a box here to the upper quartile here. So I'm going to draw that box. Hopefully you can see that. I'm sorry that it goes through there. Okay. And it's just kind of, my box goes around the dots, okay, above and below. Okay, then I draw a line segment that connects the least value to the lower quartile, and a line segment that connects the upper quartile to the greatest value. So sometimes box plots are called box and whisker plots because these lines out to the side are considered whiskers. So you may hear it referred to as that. So I drew a box from the lower quartile to the upper quartile, made a box around that, those dots, and then I drew a line from the least value to the lower quartile and from the greatest value to the upper quartile, kind of coming in, okay? All right. Now, some things, that's basically how you created a box plot, but now what we're going to do is talk about how to find the interquartile range. And to find the interquartile range, basically that means, what is the difference between the lower quartile and the upper quartile? So I take the upper quartile because it's going to be the bigger number, in this case 61.5, and I'm going to subtract the lower quartile, which is 57. I'm going to subtract it, and I get 4.5, and that is my interquartile range. It just means the difference between the lower quartile and the upper quartile. So that's my answer there. That's pretty easy. Now, if I'm just asked to find the range, then I just take the greatest value, subtract the least value. So 65 minus 54, and my range is 11. So the range and the interquartile range are different because the range is really from the least to the greatest value, and the interquartile range is the range from the lower quartile to the upper quartile. Okay, in box number 5, we're going to do an example together, and it says find the range of each set of data. Which city's data has the greater range? So for Miami, I'm going to take the greatest value because I'm just looking for the range, not the interquartile range. I'm just looking for the range. So my greatest number for Miami is 91. Okay, and they're right here. I'm going to subtract the least value for Miami, which is 76. If I subtract that out, that's my range for Miami is 15. Okay. For Chicago, I'll change my color here. My greatest value is 84. And my least value is 31. So I subtract those and I get 53. So Chicago has the greatest range. This has the biggest difference of numbers. So that's the answer to my question. Okay, so when you're done, this is what it should look like. Box 1 has the definitions. Box 2 tells the steps, the things you need to find, and it has, we did an example together where we found those values. And on the other side, or wherever you could fit it, however you worked it out, you had step 3 where we drew a box plot. And this shows you a little bit neater how it looks. So you can use this if my other example was messy. And then finding the interquartile and the range, and then our example between Miami and Chicago. And that's it, and you're done. Have a good day.